And Mara? Okay. What happened to Mara? Mara, you're kicked out? Mara's kicked out. Okay. So today we're going to talk about right triangle trigonometry. So the topic is right triangle trigonometry. Trigonometry, right triangle trigonometry. Okay, raise your hand if you've done right triangle trigonometry before. You remember what it is. Right triangle trigonometry. Okay, you guys don't remember that from last year? I only see a couple of you, so I got to ask you personally since you're not raising your hands. Ian, you never heard of right triangle trigonometry?
Nah.
How about SOHCAHTOA?
Oh yeah, I remember that.
Okay, raise your hand if you've heard of SOHCAHTOA. I've heard of SOHCAHTOA. Okay. So let's go over right triangle trigonometry, okay? So for example, let's go like this. You guys are with me here. Let's draw a right triangle like this. And very quickly, let's do Godzilla time right now. Let's do Godzilla time. You don't have to write this down. This is Godzilla time. Let me get some, this is Godzilla time. From spraying my board, my stick got wet. So, dude, this morning, you're not even going to believe it. The cats peed on the floor. I had to clean it all up. Oh, my gosh. Cat pee. Terrible. What if Godzilla had to go to the bathroom? Like he went to the... That would be horrible. But you think about it, a creature like that couldn't live... How much water would he have to drink? Like, he can't drink the ocean water. Or would he? Could he drink ocean water? Okay, Godzilla time. So, let's say I have a triangle here. 3, 4, and I ask you to solve for that side. How would you solve for that side? Someone yelled out or someone called someone. How would you solve for that side? How would you solve for that side? This side here, C. How would you solve for C?
A squared plus B squared equals C squared.
Yes, very good. Thank you, Samantha. So we say A squared plus B squared equals C squared, or A and B are the legs, and C is the hypotenuse, right? So I'm going to say 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. 25 equals C squared. I take the square root, and C equals 5. Okay, you didn't have to write that down, but raise your hand. Remember that? Remember that? Raise your hand if you remember that. Raise your hands. I'm looking at you. You don't know, right? I'm telling you how to do. Just got to make sure you have that. Because if you don't, I'm going to do it. And then so many times, I'm going to make it go, and I'm going to take that $77, and I'm just going to go right into this thing. And you're not going to even understand how it's going to do the thing. Because if you do, it's going to hurt like I did. And if it does, you are going to say, and you will regret it for the rest of your life. All right. How am I doing, Billy?
Good.
Am I getting a little too animated here? I don't want to make you feel like, am I intimidating? Am I making you feel uncomfortable, Billy? Let me know.
No.
Okay, good. Sorry to yell at you like that. I didn't mean to yell. Dennis, I'm sorry I yelled. I shouldn't have done that. I crossed the line, Dennis. I'm sorry.
It's okay.
Okay, thanks, man. All right. So, we can find this out by using the Pythagorean theorem. Now, right triangle trigonometry allows us to find the missing sides. Instead of giving 2 sides, we can use a side and 1 angle. Now, let's talk about perspective. You must write this down now. Okay, Godzilla time is over. Write this down. So we have a right triangle. Okay, you have a right triangle. Draw a right triangle. You are drawing the right triangle. And let's have an angle here called theta. I'll let you guys draw that right triangle. Now, this is all about perspective from that angle, okay? This angle right here, I have this side and I have this side. This side, I would say, is next to the angle theta, right? We call it next to. What do I call that side that's next to the angle? What do I call that side? Someone yell it out so I don't have to call on you. What do I call this side? Kokatoa. Ethan, what do I call that side?
Adjacent?
Yes, adjacent. It is next to, we call it adjacent. But this is also next to too, but I don't call that side the adjacent side. What do I call that side right there, Brett? What do I call this side?
I don't know.
What did you say?
Hypotenuse.
Yes. That's the hypotenuse side because it's opposite of the right angle. Now, Alonzo, what do I call this side that is opposite of the angle? What do I call that side?
The opposite.
It's the opposite side. Now, based on this angle, this side's the adjacent side, this side's the hypotenuse, and this side's the opposite side. Raise your hand. I remember that from last year, Sensei. Raise your hand. Raise your hand if you remember that from last year. Okay, cool. I'm seeing lots of hands. Great. Now, you don't have, this is what, I'm going to draw another triangle. You don't have to draw this other triangle. You don't have to draw it, but you can go ahead and look at it. So what if my angle, instead of being there, I have my angle, here. And my angle, let's call it alpha. You guys see that there, alpha? Now what's my opposite, adjacent, and hypotenuse? Now this side, what's this side going to be? What is this side going to be? Let's go with Angel Lopez. What would this side be? Opposite, adjacent, or hypotenuse?
The adjacent?
Adjacent, yes. It's my adjacent side. Notice my adjacent was here because I was looking at that angle. Now I'm looking at this angle. This is my adjacent. So what's this side here then? Sam Adams, what's this side here? Sam.
Hold on.
Huh?
The opposite side.
Yes. And now what's this side here? It's the opposite, but this side is always the hypotenuse. Okay, so hypotenuse. So remember, these can change depending on what angle you're looking at. If you look at this angle, opposite, adjacent, hypotenuse. If you look at this angle, opposite, adjacent, hypotenuse. Okay. So now, I'm going to erase this. Let's talk about right triangle trigonometry. But before we do, I'm going to talk about, you guys know I'm a fan of Saitama, right? Saitama, One Punch Man, right? You can destroy anything in one punch. But I always wonder, you guys ever wonder who would win in a fight? Saitama or Goku, right? Who would win in a fight? Saitama or Goku? Always wonder. I personally think Saitama would win. That's me personally. But Goku can destroy planets, so what, you know what I mean? Now, Goku shoots cannonballs. Shoots the cannonballs, right? Fireballs. What does Goku say when he shoots his fireballs? And that's how you remember right triangle trigonometry, right? Whenever Goku shoots his fireball, he says, "So Katoa," right? That's what Goku says. So we go ahead and say what Goku says is "So Katoa," and this will help us. Katoa will help us with our right triangle trigonometry. So, sine is equal to opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent is equal to opposite over adjacent. So let's go ahead and say we're going to do sine of theta is equal to the opposite side divided by the hypotenuse side. Sine is spelled like this. That's the actual spelling of sine, S-I-N-E, but we get to leave the E out. Cosine of theta is blank over blank. What's cosine equal to? Nathaniel, what's cosine equal to? What over what do you think? Nathaniel?
Adjacent over hypotenuse.
Yes, thanks for answering so quickly. Cosine is spelled like this. Cosine. Cosine. You don't have to write that, but just so you know. Tangent of theta is equal to what over what? Tangent of theta, Elise, what is tangent of theta equal to?
What was the question?
Yes, it is opposite over adjacent. Very good, Elise. Now, tangent is spelled like this. Tangent. Tangent. You don't have to write down, but just so you know, right? That's why people say sin. It's not sin, it's sine, right? Cos, it's not cos, it's cosine. Now, there are 3 other trigonometric functions. Okay, there are 3 others that you don't know, but they're really not that hard. There is also cosecant of theta. Now, cosecant is equal to hypotenuse over opposite. Notice the cosecant is the reciprocal of the sine. Okay? Cosecant is just sine flipped like that. Cosecant is spelled like this. Cosecant. Now, secant of theta, spelled this, secant, is equal to, look at cosine, is hypotenuse over adjacent. Hypotenuse over adjacent. And then finally, cotangent of theta is equal to this reciprocal opposite over adjacent. These are new, but they're just cosecant is sine flip, secant is cosine flip, and cotangent is tangent flip. All right, Alonzo. You be right back, Alonzo. That's what I'm talking about.
Mr. Sanchez.
Yes, Jackson.
You wrote cotangent as the same as tangent.
Oh, wait. Oh, shoot. Thanks, man. Cotangent is the reciprocal, is adjacent over opposite. Sorry, thank you. Big bad deal. Is adjacent over opposite. That's my cotangent. Thank you, Jackson. Fix that. Sorry, fix it. That's pretty much it for the lesson. Now, our assignment is, what's my assignment? I lost my worksheet. I lost it. I lost my worksheet. I lost it. No, I didn't. Here's the assignment. Write this down. Page 414, 5 through 37, every other odd. That's the assignment. Okay, so let's go ahead and do the assignment and see what we get. I'm going to erase this and let's see. Are there any questions before I ask Wagner? Are there any questions? I'm going to erase this in 10 seconds unless you need it. 5, 4, 3, 2, 1. Okay. You guys have Sokoto up there. So number 5 is listed as this. Number 5. Number 5, we're doing every other odd. Number 5 I have here this side, drink, and drink, and drink, and drink, 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 drink. Now they give you this side. This side's 9, this side's 12, and we're using this side theta. They want you to find all 6 trigonomic functions. We're asked to find sine, cosine, tangent, cosecant, secant, and cotangent for all of these. That's what we're asked to solve for, okay? But I need to find that missing side. How do I solve for the hypotenuse? Okay, Kevin, how do I solve for the hypotenuse here?
You're covering the board. Oh, well, 9 squared plus 12 squared.
Yeah, equals what? C squared, right? 81 plus 144 equals C squared. $225. So C equals 15. So we got that. So we solved using the Pythagorean theorem. Now I can do our sine, cosine, tangent, cosecant, secant, cotangent. Okay, so I'm sure you guys know this. I'm going to erase this in 10 seconds. Are there any questions? All right. Hey, Angel Lopez, what does Goku say?
Sin Costan.
What?
Sokatoa.
Sokatoa. Sokatoa. Goku. Emma.
Yeah.
Who would win in a battle? Saitama or Goku?
Saitama.
Yeah, that's what I'm talking about. Okay, so let's do sine. Sine of theta. Sine of theta is opposite over hypotenuse. What's my sine of theta? Let's reduce it. Brett, what's my sine of theta?
Wait, let me see. Opposite over hypotenuse. What? 12. 12 over 15.
12 over 15, which reduces both divisible by 3, 4/5. Cosine of theta. What does that equal to? Let's go with Elise. What's cosine of theta?
I'm not sure.
Yes, very good. It's 9 over 15. Very good, Elise. And then we can reduce the fraction by dividing by 3, 3 over 5. Raise your hand if you understand that. Bring your hand up so I can see. I get that, Sensei. I got cosine. Okay, cool. So let's do tan of theta. What's tan theta equal to? Let's go with Ethan. What's tan of theta?
4 over 3? Or 12 over 9?
Over adjacent, which is 12 over 9, and that reduces to 4 over 3. You are correct. Now, what is cosecant of theta? What is secant of theta? And what is cotant of theta? Okay, what's my cosecant of theta? Ian, what's cosecant of theta?
Hold on. Isn't it 15 over 12? Right?
Yeah, but let's use this 5. Since it's the reciprocal of this, since I have this reduced, I'm gonna do 5 over 4. But you're right, you just didn't simplify. Right, Ian? Okay, Linda, what's the secant of theta?
15 over 9.
Okay, let's reduce. Can I use this one? 5 over 3. You're right. We just didn't reduce. Right, Linda? You cool? Linda, you good? I'm looking
Yeah, I'm
at you.
good.
Okay, cool. Thomas, what's my cotangent? Give me reduced.
3/4.
There you go. That's it. All right, can I move on? Now, I'm looking at 9, and 9 gets a little bit tricky, so I'm going to do 9 really quick. So are there any questions? I'm going to erase this in 10 seconds, unless you need it. 10 seconds. Okay, I'm erasing it. Okay, I'm erasing this in 5, 4, 3, 2, 1. Okay, now, that's pretty straightforward, but it gets a little bit tricky. You guys know you cannot have a square root in the denominator of a function, of a fraction. You can't have a square root. So some of these I'm going to have a square root, and we have to rationalize the fraction, okay? So what do you mean by that, Sensei? I'll show you in just a second. $18.10. And we have a like that. Okay, that's good. Okay, here's my triangle. This is number 9. Okay, so now we have angle theta here. Here's my angle. This is my right angle. Now this is 10 and 18. Now notice this is my hypotenuse. Actually, let me see. Would this be hard? Actually, I don't know if I want to do. Oh, I guess I'll do that since I started it. Okay, so I'm going to say 10 squared plus b squared equals 18 squared, which is 100 plus b squared equals 18 times 18. What's that? $324. And then subtract 100. B squared equals 224. And I get 14. Okay, so let's find the square root. So b squared is going to be, b is going to equal to square root of 224. 224, let's break it down. 224 divided by 16? 14. 16 times 14. 16 is 4 and 4. 4 is 2 and 2. 4 is 2 and 2. 14 is 2 and 7. So square root of 224 is 2 times 2 times 2 times 2 times 2 times 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2's in the 7. So that breaks down into, right, gets out of jail, 2. There's another 2. So this is 4 root 14. I did that quick because I'm assuming you know how to do that. 4 root 14 is that side. Now, I'm going to erase this. Now I can do my SOHCAHTOA. The problem is I can't have this in the denominator. I can't have this squared in the denominator. So let's go ahead and see what's going to happen here. So sine of theta, cosine of theta, and then tan of theta. Sine of theta is opposite over adjacent, no problem. 4 square root 14 over 18. Both of these are divisible by 2, which is 2 root 14 over 9. Okay, I'm assuming you guys know that I'm going fast. Am I going too fast? Carlos, am I going too fast? What?
No, you're doing fine.
Okay, cool. Let's see, Jackson, am I going too fast?
Not right now, but before you were.
Okay, slow me up if I'm going too fast and turn your camera on. Sam
Okay.
Adams, am I going too fast?
You're good. I'll turn my camera on right now. I'm just doing something.
It's okay. I like watching you do stuff. It's okay. That probably sounded creepy. I didn't mean to. That sounded creepy. I didn't mean to sound creepy.
Okay.
Okay, cosine is adjacent over hypotenuse, which is 10 over 18, reduces to 5/9 tangent. Okay, now watch. No, this is fine. Is opposite over adjacent, which is 4 root 14 over adjacent 10, which is 2 root 14 over 5. Okay, here are my answers right there. Okay, now let's do secant, cosecant, and cotangent. Watch this. That didn't even work. Cosecant. Okay, there we go. Cosecant is the reciprocal of secant. Now watch this. Cosecant is 9 over 2 root 14. I cannot have that square root 14 in the denominator. So I'm going to solve it right here. Okay? So I can't have this 9 over 2 root 14. I can't have the square root 14 in the denominator. So what I'm going to do is I'm going to multiply the numerator and denominator by the square root of 14. Just multiply it by itself. Now, square root of 14 times the square root of 14 is just, well, 9 times square root of 14 is 9 square root of 14. Square root of 14 times the square root of 14 is just 14. This times this becomes 14. And then 2 times 14 is 28. So it's 9 root 14 over 28. That's called radicalizing the fraction. So that is going to be my correct answer. 9 root 14 over 28. 9 root 14. I'm going to get out of the way. There, I'm out of the way. There's the complete answer. Now, cosecant, or cosine is secant. Theta is 9 over 5. Just flip that. That's easy. Now, look what happens here with tan of theta. Cotan of theta. Cotan of theta is equal to 5 over 2 root 14. Okay. I can't have that root 14 in the denominator. So, Brett, how do I get rid of that root 14? How do I get rid of this?
Oh, you put it at the top.
I multiply the numerator and the denominator by root 14. Is that what you meant?
Yeah.
Okay. You guys see that? So again, so my numerator is 5 root 14, right? 500, and 14, root 14 times root 14. What's root 14 times root 14, Alonzo? What is root 14 times root 14, Alonzo?
I don't know.
14.
14.
14. Root 14, so this is root 14 times root 4, so it's 2 times 14, which is 5 root 14 over 28. Alonzo, does that make sense? Or no?
I was confused for a second, but I'm good now.
Okay, so it does make sense. Very good. And so those are your answers for all 6. Okay, I'm going to go a little bit faster here. How are we doing on time? I still have 40.
Behind.
Huh? Oh, slow up. You saying slow up, Abraham?
Yeah, I'm still behind.
No problem. Let me know when you're ready. I'm looking to see if they gave me a classroom. All right. Abraham, how you doing, man?
I'm on the last one.
All right, man. Take your time. Ain't too much for me, Jam.
Alright, I'm finished.
All right, anyone else need it? Okay, so I'm going to go over number 13 very quickly because it's the same idea. I might not even do the whole thing because I think you guys can do it on your own. So there's a lot to go over. I'm going to erase this. Let's look at 13 next. That was 9. Let's look at 13 next. I have here, this is 13. Now 13, all they tell us is that sine of theta, all they tell us is that sine of theta is equal to 7 over 11. Sine of theta is equal to 7. That's all they tell us. Find all the other trigonomic functions. Find cosine, tangent, cosecant, secant, and cotangent. All you have to do is just, let's draw a picture, and it's easy. Draw our picture, whatever. Let's draw any triangle that we want. I'll draw it right down here. I'll draw a triangle. Blink. 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 And let's put theta right there. Okay, that's what I decided. You could draw another type of triangle, but as long as it's a right triangle and you have a theta in it. It has to be a right triangle, right? I'll give you a second to draw this triangle, then we'll fill in what we know. Remember, sine is opposite over hypotenuse, right? Sine is opposite over hypotenuse. Ba-da-ba-ba-ba, bow, ba-da-ba-ba-ba. Ba, ba, da, ba, ba, ba. Okay. So now that I have this, I know sine is opposite over hypotenuse. So I know this is 7, and this is 11, right? Hypotenuse. I just have to figure out this by going 7 squared plus b squared equals 11 squared, right? Solve for that side. That's the hypotenuse. So it's 49 plus b squared equals 121. I subtract 49 on both sides. I'm just solving it. You guys can solve it. You can solve it on your own. 121 minus 49. And then we take this, it's 72. I know, I'm right here. B squared equals 72. Let's get the square root of 72. 72 is 8 and 9. 8 is 2 and 4. 2 and 2. 3 and 3. So 72 is the square root of 2 times 2 times 2 times 3 times 3, which is 2, 3. 2 times 3 is 6 root 2. So this side is 6 root 2. I'll give you a second to calculate. I didn't do that slow because I know you guys can do that. So you guys just calculate that out. Make sure you get 6 root 2, and then we'll move on. I see a lot of you still writing. That's fine. That's fine. Maybe I'll tell you a joke while you guys are writing those out. Why are there only 239 beans in Irish stew? Irish stew. 239. You can't put more than 239 beans. You have to put exactly 239 beans in Irish stew. Exactly 239 if you're making it. You know that? Do you know why you put only 239 beans in Irish stew? Because if you put one more, it'd be too farty. too farty. No? How am I doing, Ian, on my jokes? How would you give me? What grade would you give that joke?
Like a C minus.
Oh man, your criticism is helping me become a better jokester, You know. So, Billy, what would you give that joke?
I'll give it a B.
B. Did you laugh inside a little bit?
No.
Oh, you're just being nice. Okay, so now that we have this is 6 root 2, I'm going to erase all this. Let's say, right, all I have to do, we have our sine. Sine of theta equals 7 over 11. Cosine of theta equals what? Tan of theta equals what? Right? Cosine, so you just go, right? 6 root 2 over 11. Tangent of theta is opposite over adjacent, 7 over 6 root 2. Now, right, I got to get rid of the root 2, right? So I go root 2 over root 2, which is 7 root 2, 6 times root 2 is 2, and then it's 7 root 2 over 12, right? Anyway, you guys do the cosecant of theta, the secant of theta, and then the cotan of theta on your own. I'll let you guys do that on your own. I'm going to move on. I'll let you guys write that down. That's 13. 17 is the same. 21 is next. I'm going to go to 21 next when you guys are ready. You guys do it at home. Finish it at home, though.
I have a question.
What's up, Abraham?
Is cosecant the opposite of cosine or sine?
Cosecant is the reciprocal of sine.
Okay.
Not the opposite would be positive. Reciprocal is the word it flips, right?
Mm-hmm.
I think that's what you probably meant, though, right? Yeah. Cosecant is reciprocal of sine. Secant is a reciprocal of cosine.
Oh, okay.
Did you have it written down when I wrote it in the notes before?
Mm-hmm. But it's just like for me, it made more sense if it's cosine, cosecant.
Yeah, exactly. You're exactly right, but it's not like that. I know what you mean. It is not like that, though. You would think cosine would go with cosecant, but it doesn't. It goes with secant. That's what you're saying, right? All right, Sam Adams. Okay.
Mr. Sanchez.
Yeah.
When after class, can you show me how you turn root 72 into 6 root 2?
Yes.
Okay.
Okay. Let's go with where are we at? That was 13. I think we're going to 21. Okay. So very quickly, I got to do a quick lesson on 21 before I do 21. Do you guys remember special right triangles, 30, 60, 90 triangles, and 45, 45, 90 triangles? Raise your hand if you remember those. You heard of them at least, 30, 60, 90 triangles or 45, 45, 90 triangles. Who needs like a quick 1 minute review on them? I need a 1 minute review. Raise your hand if you want a 1 minute review. Okay, I'm gonna do a quick review. So here we go. Let's talk about the 30, 60, 90 triangle. Now, the 30, 60, 90 triangle is a ratio, okay? So if I have a triangle that looks like this, and say this side is 30 degrees, this side is 60 degrees, and this side is 90 degrees. They add up to 180 degrees, right? Let's say that this side is x. This side is x. Opposite of the 30 is x, wherever that is. The 60 will be x times the square root of 3. Whatever this is, you multiply by the square root of 3, you get this. You have the 60, you divide by the square root of 3 to get this side. And the hypotenuse is going to be 2 times x. To get the hypotenuse, you multiply this by 2, you get the hypotenuse. Now, a lot of people say, like, people go like this. If I have this side, but I want this side, I multiply by the square root of 3. But if I'm given this side, and I want to solve for this side, I divide by the square root of 3. Okay? If I have this side and I want this side, I multiply by 2. But if I have this side and I want to figure out this side, instead of multiplying by the square root of 2, I divide by the square, I divide by 2, whole 2. So on 21, we're given a triangle. Now this triangle is not going the same way that I drew it. It goes like this. This is 21. Now 21, I'm giving this side, this is 60 degrees. This is 90 degrees. This is 9. So this has to be my 30 degrees, right? So now this is my hypotenuse, right? This is my 2 times x side, right? Where's my x side? My x side is here. Remember, you go to the 2x, the x side, I divide by 2. So I divide by 2. So this is 9 divided by 2, or 4.5. Are there any questions on 21? Raise your hand if you understand 21. I understand how you got that, Sensei. This is review. Okay, not even half of you are raising your hands. So if you have a question, now's your time to speak. Otherwise, I'm moving on. Okay, now all the hands are popping up. I can't read your minds. If you don't raise your hand, I can't read your minds. Okay. Now, 25 is a 45, 45, 90 triangle. Raise your hand if you want me to do a quick review on the 45, 45, 90 triangle. Sensei, show me the 45, 45, 90. Okay, I'll do the 45, 45, 90 real quick. I'm going to erase this in 10 seconds unless someone needs it. 5, 4, 3, 2, 1. So we're at 25. Before I do 25, let's talk about the ratio of 45, 45, 90 triangle. So 45, 45, 90. I'm just going to draw it the regular way I draw it. It's all flipped around on the, oh, I just dropped my pen. 45, 45, 90. 45, 45, 90. So this is 45. This is 45. Now this, okay, if this side is x, then this side will also be x. So they're equal. And this side will be x times the square root of 2. So if you're given this side, you multiply it by the square root of 2 to get this side. Given this side, you divide by the square root of 2 to get that side. Okay? So that's my 1 minute review. I did it in like 30 seconds. So 25 looks like this. A triangle looks like this. So 45. I know I'm in the way. I'm not using my invisible powers now. So this is 8. So what's the measurement of that side going to be? What's the x going to be? All right, that's my question. Who have I not called it? I'm trying to call everyone even. Thomas Servin.
Yeah.
What's x equal to?
I don't know.
Really? Am I going too fast, Thomas?
8.
Yeah, kind of.
Okay, my fault. Do you have questions, Thomas? Or am I going so fast you can't even ask questions? Thomas, you have a question, or am I going too fast so you can't even ask questions?
Oh, you're going too fast. I can't even ask the question.
All right, it's my fault then. I did the 45, 45, 90 triangle as a quick review. Well, Thomas, since you're here, I'm going to work with you. Here, look here, Thomas. I'll go slower on this one. Thomas, keep your microphone on. It's 45,
Okay.
45, 90, right?
Yeah,
What do you notice about these two sides?
they're both x's
Yeah, so they are,
equal to each other?
they're equal to each other. So these are the legs, right?
Yeah,
Okay, do you see this 45, 45, 90 triangle?
yeah,
Okay, what's this, the leg, right?
yeah.
The leg.
So it equals 8?
There you go. Boom! Okay, is that better, Thomas? I feel better as a teacher. I blame myself.
Yeah, thank you.
All right, I'm going to go over one more problem. $29. This is the last one I'm going to go over. You guys can do the rest on your own. 29 asks you this. Here's 29. 29 is equal to, they want us to solve cosecant of 59 degrees. Now, what is cosecant equal to? The reciprocal of what? right? What is cosecant equal to? The reciprocal of sine, cosine, or tangent? Julissa, what is cosecant equal to?
I'm not sure.
Give it a guess. The reciprocal of sine, cosine, or tangent. Abraham said a good thing that I kind of helped us out a little bit. Is it the reciprocal of sine, cosine, or tangent, Julissa?
Oh, sine?
Yes. Remember, because it's not with the c. It's the reciprocal of sine. Okay, so another way to say reciprocal. You guys know this is Godzilla time, real quick. Do you know the reciprocal of 5 over 9 is equal to 9 over 5? But the reciprocal of those are the reciprocals. Do you know another way you could write the reciprocal is you just go like this: 1 over 5 over 9 is equal to 9 over 5. If you put a 1 over it, it flips it. If you put a 1 over it, it flips it. So to make this the reciprocal of cosine, since it goes with sine, this is equal to 1 over sine 59 degrees. So that's how you solve it. How do you do that, Sensei? Well, on your calculator, you guys need your trigonometry. You guys need your scientific calculator. You need the scientific calculator to solve this. Make sure you get one by tomorrow. You need a scientific calculator tomorrow. So here's how you enter it in your calculator. By the way, make sure your calculator is in degrees. You're going to go like this. To calculate this, you're going to hit on your calculator 1 over x. Hit the 1 over x button because it makes it go like that. And then hit the parentheses sine. Hit sine. Then I think you gotta put parentheses in it. Let me think. So you get 1 over x. You guys hit 1 over x on your calculator, which is what I'm doing. One over x, and then hit sine. Then hit sine. Hit sine. And then 59. And then close parentheses. Make sure you get it in parentheses. Make sure that 59 gets in the parentheses and then hit equals. And you should get 1.167. Round it to 3 decimal places. 1.167. And if you got that, then you're good. Are there any questions? All right, if there are no questions, remember, I don't think I'll be here tomorrow in the classroom because they're kicking me out. And I'm trying to figure out if they found one for me, so don't expect me to be here. But I'll be here on Thursday. Thursday is a minimum day. Thursday is a minimum day. Remember, Thursday is a minimum day. Okay. Are there any questions? All right. I love you guys. I'll see you tomorrow. Love you, Alonzo.